Imagine this, you are building a website. You want to make sure it works well for everyone. This means it needs to be easy to use. It also needs to be free of errors. This is where behavior-driven development, or BDD, comes in. BDD is a way to plan and test software. It focuses on how the software should behave from a user's perspective. BDD helps everyone understand what the software should do. Developers, testers, and business stakeholders all work together. They use simple, clear language to describe the desired outcomes. This collaborative approach helps to prevent misunderstandings and costly rework later on. At the heart of BDD are user stories. These stories describe how a user interacts with the system to achieve a specific goal. Each story is broken down into scenarios. These scenarios outline specific situations and the expected outcomes. BDD is not just about writing tests, it's about building a shared understanding of what we are building and why. This shared understanding is crucial for delivering high-quality software that meets the needs of its users. By focusing on user behavior, BDD ensures that the final product is intuitive and user-friendly. It bridges the gap between technical and non-technical team members. Ultimately, BDD helps teams deliver software that truly meets user needs and expectations. In software development, miscommunication can be a major headache. It often leads to delays, increased costs, and frustration among team members. Developers might interpret requirements differently from business analysts, leading to inconsistencies in the final product. Testers might not have a clear picture of what to test, resulting in missed bugs and lower quality software. This is where BDD, or behavior-driven development, shines. It bridges the communication gap between technical and non-technical team members, ensuring everyone is aligned. BDD uses a common language called Gherkin, which is easy for everyone to understand. Gherkin is a plain text language that reads like natural language, making it accessible to all team members. It uses keywords like feature, scenario, given, when, and then to structure scenarios, providing a clear framework. This makes it easy for everyone involved to understand the behavior being described, reducing misunderstandings. For example, imagine a scenario where a user wants to log into an online store. The steps are clearly defined. The Gherkin scenario might look like this. Feature, user login, which sets the context. Scenario, successful login with valid credentials detailing the specific situation. Given, I am on the login page, setting the initial condition. When I enter my email address and password, describing the action taken. And I click the log in button specifying the trigger. Then I should be redirected to my account page outlining the expected outcome. This clear and concise language ensures that everyone is on the same page, fostering better understanding. It also helps to uncover any ambiguities in the requirements early on, preventing costly errors later. This leads to better collaboration, fewer defects, and a smoother development process, ultimately resulting in a more successful project. Now that you understand the benefits of BDD, let's dive into how to implement it using PyTest BDD. PyTest BD is a plugin for the popular PyTest testing framework that allows you to write BDD-style tests in Python. First things first, you need to set up your environment. If you don't have Python installed, download and install the latest version from the official website. Once you have Python up and running, open your terminal or command prompt and install PyTest and PyTest BD using pip install PyTest, PyTest bud with PyTest BD installed. You're ready to start writing your first BDD tests. Setting up PyTest BD is straightforward. This ease of setup makes it an accessible choice for teams looking to adopt BDD. In PyTest BDD, test scenarios are written in feature files. These files use the Gherkin language to describe the behavior of your application. Let's create a simple feature file for a basic calculator application. Create a new directory called in your project's root directory. Inside the directory, create a file named and add the following content: feature, calculator, scenario, adding 2 numbers given. I have entered 50 into the calculator and I have entered 70 into the calculator. When I press add, then the result should be 120 on the screen. This feature file describes a single scenario where a user adds 2 numbers using a calculator. The scenario outlines the steps involved and the expected outcome. Feature files act as a blueprint for your tests. They clearly define the behavior you want to achieve, making your test suite more readable and maintainable. Section 5. Defining steps with PyTest BDD. Now that you have your feature file, it's time to write the Python code that will execute the steps described in the scenario. This is where the magic happens, transforming written scenarios into actionable code. These code snippets are called step definitions. They serve as the bridge between your feature file and the actual test code. Create a directory named steps inside your tests directory. This will help keep your project organized. Inside the steps directory, create a file named test_steps.py. This file will contain all your step definitions. Add the following code to the file Python from pytest_bdd import scenarios given when then scenarios / features calculator feature. A given, I've entered 50 into the calculator, def step_impl. A given, I have entered 70 into the calculator, def step_impl. Pass, but when I press add, def step_impl. Then the result should be 120 on the screen, def step_impl. Each step definition is decorated with a PyTest BDD decorator that corresponds to the Gherkin keyword in the feature file. This makes it easy to map the steps in your feature file to the code that will execute them. Step definitions bring your feature files to life. They are the glue that binds your written scenarios to the actual test code. They translate the Gherkin steps into executable code, allowing you to automate the testing process. This ensures that your application behaves as expected, making your testing more efficient and reliable. Section 6. Parameterization, adding flexibility to your tests. Hard-coding values in your feature files can make your tests brittle. PyTest BDD allows you to parameterize your scenarios, making them more flexible and reusable. Let's modify our file to use parameterization. Feature calculator scenario outline, adding two numbers given I have entered into the calculator and I have entered into the calculator. When I press add, then the result should be on the screen. Examples num1, num2, result 50, 70, 100, 20, 25, 25, 50. In this updated feature file, we've introduced a scenario outline and an examples table. The table provides different sets of input values and expected results. Parameterization helps you avoid code duplication and makes your tests more concise and maintainable. It also allows you to test a wider range of inputs with minimal effort. Section 7. Scenario outlines, testing multiple scenarios efficiently. Scenario outlines, combined with parameterization, allow you to test multiple scenarios with a single feature file. This is particularly useful when you have similar scenarios with varying inputs and outputs. In our updated file, we've already defined a scenario outline and provided two sets of examples. PyTest BDD will automatically generate and execute a test case for each row in the examples table. This means we are now testing two scenarios, adding 50 and 70 and adding 25 and 25. Scenario outlines promote code reuse and make your test suite more efficient. They help you cover a broader range of test cases without writing repetitive code. Section 8. Organizing tests with tags. As your test suite grows, it becomes essential to organize your tests for better management and execution. PyTest BDD allows you to tag scenarios with custom labels, making it easy to select and run specific tests. You can add tags to your scenarios in the feature file using the syntax. For instance, we can tag our calculator scenarios based on their functionality. Feature calculator at addition scenario outline, adding two numbers. Now you can run all addition scenarios using the command. Tags provide a flexible way to categorize and filter your tests. This is especially useful in large projects where you might have hundreds or even thousands of tests. Section 9. Conclusion. Behavior-driven development with PyTest BDD offers a powerful way to improve your testing process. By focusing on user behavior and using a common language, BDD fosters collaboration and reduces misunderstandings. PyTest BDD provides the tools to implement BDD effectively, making your tests more readable, maintainable, and robust. From writing expressive feature files to defining precise step definitions, PyTest BDD empowers you to create a comprehensive test suite that reflects the true behavior of your application. Its advanced features like parameterization, scenario outlines, and tagging further enhance your testing efficiency. By embracing BDD and leveraging the capabilities of PyTest BDD, you can build a higher quality software that meets user expectations and stands the test of time.